So hi everyone, welcome to our monthly OpenLineage TSC meeting. I'll go ahead and get started with the agenda. So quick reminder, these meetings are being recorded and posted on our website, wiki, YouTube, and such. We like to start the meeting with a quick roll call. So on my screen, I'll start with Maciej.
Hey, I'm Maciej. I'm a TC member and software engineer at Datadog.
Hi, Maciej. Next up is Pavel.
Hi, I'm Pavel. I'm software engineer at Getting Data and TSC member in OpenLineage. Happy to be here. Thank you.
Thank you, Pavel. Jakub.
Hello everyone, I'm Jakub. I'm PM and former software engineer at IBM. So happy to be here after a couple of months of missing the call.
Good to see you again. And last but not least, Tomasz.
Tomasz Nazarevich from Getting Data, also TSC member.
Good to see you again, Tomasz. And I'm Harel. I'm an engineering manager at Datadog and also TSC member. All right. Quick admin link on all the ways to get in touch with us. On the agenda today, some quick announcements. I'll quickly show recent release, even though it's not yet fully released. So this is in the oven right now. Thank you, Maciej, for running the release. And then Pavel will present on debugging Spark connector with OpenLineage. Then we'll open it up to open discussion if anyone would like to bring up anything. So one quick announcement, OpenLineage will be presenting at the Airflow Summit in October in Seattle. We'll be giving a talk about simplifying data lineage and how OpenLineage empowers Airflow and beyond. The talk will be held there. If anyone is attending Airflow Summit, please join us. As a reminder, also last week we talked about Pavel's talk at Current. Sorry, not last week, but last month. I think the recording is up, so please refer to that and watch Pavel's awesome talk at the Confluent conference. Another cool announcement that hopefully we can ask Fiore to talk about in our next TSC meeting is Debezium now added native support for OpenLineage. So that's available from version 3.2.0 beta 2. Thanks to the Debezium team for making that happen as part of Debezium. Great contribution. Very great to see the ingestion side of things in the OpenLineage community. It's very awesome. All right. I didn't have a lot of time to prepare this because literally the release notes were shipped like an hour ago, more or less. But and apologies for not having the contributors and probably more details here. But as of today, we'll have version 1.34.0 with adding the Hive integration to OpenLineage. A bunch of improvements on Spark, like supporting dynamic frames and call-level lineage for some use cases for JDBC, some added facets and improved facets. Same for DBT, some added facets and support for more providers on DBT, more facet improvements on Flink and metadata extracted, bunch of improvements to the Java and Python clients, and much, much more. Check out the release notes. And with that, I will hand it off to Pavel.
Yeah, thank you, Harel. Can you still share the screen and just, move the slides when asked?
Yes.
So that's great. So I would like briefly to describe the feature or the problem I was working recently on and I'm still working on. And I'm really hoping to get the feedback from the community. Perhaps someone else have the same problem or similar, or would love to change the approach or enhance it with some more detailed things. So yeah, you called it debugging. Just before the call, I rephrased it to the quality of the lineage collected by Spark connector. And yeah, on the next slide, I tried to present the problem. And the problem is that imagine a company that gets OpenLineage events sent through and emitted through the Spark connector from their customers. And yeah, the customers are asking, what's the quality of the lineage you collect? Are there any guarantees about the completeness of the lineage? Yeah. So how can we measure the quality? Are we getting like 100% of lineage, or just 70 or 83%, or what's the number? Yeah. How good are we at doing the thing? Yeah. So initially, a few years back, you could have just turned on the Spark integration, Spark connector, and you saw some graph on the backend of your preference. Yeah. And it's cool that you see the lineage graph, but it's good to know how accurate it is. And the extra complexity when working for this customer is that, you know, if you have an organization that turns on globally OpenLineage, you can enrich OpenLineage events, or you can have extra metadata sent through other means. Like you can get the logs, for instance, the logs telling that the OpenLineage integration had some issues. You can have the metrics sent to metric backend, and it's the feature implemented by the great Maciej, who is here with us today. So you can correlate, you know, OpenLineage events with amounts of OpenLineage events that you're expected to send, and see if these are the same numbers, and if you were successful at this. And however, in this case, it's not the case. I can only rely on the OpenLineage events on their own, which is perhaps not the perfect scenario, but this is what it is. And you know, when addressing this problem, I think there are like two important things that should be addressed. First one is to ensure that OpenLineage event is emitted most of the time. So even if the integration encounters some problems and some unexpected behavior, I would love it to emit OpenLineage event. The second thing is I would love to OpenLineage events to be self-containing and to have all the diagnostics information possible. So whenever we encounter a problem, I would like to have a facet that describes what kind of the problem we had, and so that I would be able on the backend to, you know, understand and investigate the problem. And you know, trying to solve those two, the first thing to solve is, yeah, get the events also when something goes wrong. And this leads us to the next slide and the feature that I'm currently working on. So in the past, we have implemented the things like circuit breakers, which allows you to stop OpenLineage integration when reaching some scenario that is not accepted, like when exceeding the allowed memory of the Spark driver, we want the OpenLineage code to stop, to make sure that the Spark job finishes correctly, to make sure that the OpenLineage does not affect the job. We also do have a timeouts capability within the circuit breaker. So, you know, if getting and emitting OpenLineage event gets more than 30 seconds, stop it. Yeah. So this assure that the job doesn't fail. But the result of this, that we will not get OpenLineage events. So we'll not even find out that such thing occurred. So currently I'm working on the PR to introduce the fine-grained timeouts. It's 3779, it's work in progress. And I would love to introduce extra settings like build datasets time percentage. So if you define a timeout for the whole integration of OpenLineage, like 30 seconds, you can say, and 80% of this time should be spent on building datasets. In case this is exceeded, you are still able to emit OpenLineage events, perhaps with some datasets skipped, but you will still, we want you to still have this information with the OpenLineage, telling you, hey, it's an OpenLineage event, but we didn't collect whole lineage. There was something wrong, yeah? So what OpenLineage integration does is it detects inputs, output datasets, collects some run facets, some job facets. So it's like building facets part. then it serializes this and emits the event to the transport of your choice. So the other setting is like facets building time percentage, which is like building run facet, job facet, and data sets. And in practice, this means it's everything apart from serializing and transporting the event, emitting it. So you can still say 80% of the timeout should be spent on gathering the facets. And if you exceed it, you still want to emit the OpenLineage event with the back facet. And the back facet is something from the next slide that actually we introduced like a year back. And the aim of this was to contain some useful information to try to find out what was wrong, or what was happening, and what's so specific about this particular run. So it contains some class path information like the Spark version, the version of the connector you're using, because perhaps you may be using the old connector, Scala version, and other things. What's your Spark deployment mode? What's your Java version? What's the OS, time zone? Perhaps some metrics that you have not sent to the metrics backend. And the last but not least, but the really meaningful part is the shortened information about the logical plan. So the logical plan is something that describes your job. It's a tree. And yeah, we want to know, it really describes what's happening within the job. We want to have the shortened and serialized logical plan within the debug facets. I mean shortened because we don't serialize objects so that they don't get huge, but we want to know what type of nodes were used. And it's really a great feature, but the concept of it is that debug should not be turned on by default. And you just should turn on it whenever you see something that's yeah, makes you want to get more data. And this leads us to another feature that actually was merged last week, and it's on the next slide, which yeah, if we can switch the slide, Harel, which I call the Smart Debug Facets. Sorry for the name, because I don't know, calling things smart is like, it's not that smart. But the thing is that I wanted to have the ability to turn on the back facet whenever something happens that we would like to have more information about. And so how does it work? So by default, Spark integration contains a list of actions that shall be skipped, that shouldn't result in OpenLineage event being emitted. And otherwise, if Spark action triggers OpenLineage event, it should contain some lineage information. It should contain inputs or outputs. And you know, if it doesn't, then it means we didn't extract the lineage correctly. If it doesn't, we would like to turn on the debug facets for the complete event. So for the entire run, we keep in the state the information if there were any inputs or outputs emitted. If not, then we turn on the back facet and attach it to the complete event. And there are two modes available: output missing, because for some users, the query, like, you know, if the output is missing, it's still okay. So imagine the select count star from table. It's the query that has no outputs, but perhaps we want to track the lineage in this scenario. But perhaps we don't. So the other mode is any missing. If there's if inputs or outputs are missing, we want to have the debug facet attached. And within the debug facet, we added an extra field containing information on why it was included. The extra feature added to this was the configurable max payload size of the debug facet. So for some backends, it's really important for the OpenLineage events to not to exceed like 1 megabyte, 2 megabytes, wherever. So you can configure it so that this facet is smaller than the configured value, to make sure that you don't flood your backend with unnecessary information. I think this is it, and I believe this is all, but perhaps not all, but it's what we could have done just by being limited to OpenLineage events and the self-contained information about the integration within it. And yeah, I'm happy to get any questions, discussion about this.
Can you go back to the second slide where you have this timeout feature? So
Yeah.
have you thought about implementing it in a way that we do multiple passes and like basically have few passes, and first one we know this is super fast, doesn't do external calls, doesn't do maybe column level lineage, and then have the second part that possibly timeouts that does more complex things and processes, I don't know, does external calls for iceberg tables, for example, does column level lineage, does other stuff. So this way we have some data always, and we don't have maybe more advanced features, but we don't time out the whole event, right?
Yeah, so I thought about it and I don't know if this is possible. So what I did is that, you know, first you try to identify the outputs, then you identify the inputs. And, you know, if you fail, if you time out with the inputs, you still have the outputs, yeah? But,
but this is like vertical lever, and I want to like flip it and do the horizontal version, where we process each node multiple times, maybe.
Yeah, so you know, the integration gets the list of dataset builders or the facets or dataset visitors, and it's hard to say which of them is time consuming, because sometimes, like the iceberg is a great example, because sometimes the integration calls Spark load table, and perhaps this means an extra call to external service that can time out. And I don't know how to protect from this, and how to
if we assume we can change this API,
like the way the Spark integration works now.
Yeah,
I don't know if it makes sense, because if you cannot load the table, then you cannot find the identifier of the dataset. And if you cannot find the identifier of the dataset, then you lose all the facets anyway. So
I mean, it makes sense when we do stuff that Spark doesn't do, right? So we generally can do what Spark does. Like driver can access Spark metadata. I mean, Spark can access iceberg metadata because it has to read the tables, right? So I don't, maybe Spark is not iceberg is not a good example, but like column level facet, I think we do much more computations, and like RDDs, especially I think has been a source of this problem in the past. So maybe we can.
Yeah, what I wanted to say is that, you know, if the problem is with getting, so I believe the problem can be mostly with getting the data identifier and the namespace. Because
that's very interesting actually for me, because I feel
but the point is if you get the problem here, there's no point in you know, generating other facets, because you will not be able to attach them.
True. I just think it's pretty much never the identifiers.
Yeah, but I get your point that, you know, it's like, it's going, what you say, it's going even deeper with the granularity. So in this case, you know, it says you cannot build inputs, but you still have an event. And what you're saying, perhaps you cannot build an input for a particular data set, but you'll still have other inputs. Yeah. And this would make sense. I would say it's just more complex on the implementation side. Yeah. But yeah, if you know how to do it, I would be happy to.
And when it comes to granularity, I have more ideas, including like reworking how this integration works. Yeah, but I feel like we should do more stuff atomically rather than try to do this giant computation. Then I mean giant. it's a problem with a giant computation when we have those jobs that like logical plan is a 20 megabyte JSON file on printed, right? It's usually not a problem, really, but
yeah. I would even say that this feature can be really helpful in convincing others to work more on the features you propose, because it will say, "Hey, you got the data. This is the amount of events that failed building data sets. We need to have more detailed view in it." But perhaps the outcome will be, "Hey, it never happens. Why to spend more time on it?" Yeah.
Yep.
Thanks for the discussion. Anyone else? Question? Comment? Definitely useful as someone who used to try to debug these situations in the past with people using the Spark integration. So I appreciate your contributions here, Pavel, on behalf of the community. All right, so that was the only item on the agenda for today. I'd like to open it up to open discussion if anyone would like to bring up any topics.
Regarding the release, one point that I forgot to discuss earlier is I think this was the biggest release we've done. There's a lot of new features, a whole new integration contributed by Tomasz here for Hive, and yeah, a lot of other fixes. So yeah, feels like it's going nice. So,
Thanks for managing releases for us all, Maciej.
I have a question, if AOB's allowed.
yeah.
Of course.
Just a general request to the community. Has anybody seen any good thinking on unstructured data lineage as yet?
Can you be a bit more, like, do you have a concrete use case in mind that you're thinking?
Yeah, we've been working and a bunch of conversations across the market with regards to ingesting unstructured data into Gen AI engines and taking unstructured data, for instance, and vectorizing it. How do you keep track of that lineage?
I see. So I guess in that case, I mean, I'll give an example use case I had in mind and how I was thinking of observability for it. So let's say it's RAG architecture, right? And there's a pipeline that's getting data and creating vector embeddings. In the cases that I've seen or heard of, it's mostly been semi-structured data running through, let's say, maybe an Airflow job, and then the observability is kind of the same as we kind of think of it. And there's the operator that writes maybe into the PG vector. I haven't seen a lot of use cases that use the more specialized vector DBs out there, but like PG vector is probably the most commonly used one I've heard of. And there we kind of just treat it as a data set, honestly.
Just the token as a package, or tokens as a package.
So, Daniel, can I ask for the use case that you have in mind, like what's the level of detail, what's the granularity that would be needed? Like, would you expect to have lineage information for individual documents, or more like a sort of metadata level information?
Certainly individual documents would be ideal. The conversations we've been having is even if we could get within the documents, when you have copy and pasting outside of documents, or a Confluent post or whatever into a Gen AI engine, and then having that Gen AI engine process that data and bring it back as a set of tokens output. Right? So where does that then go? So what is that lineage and workflow?
And how would you leverage the lineage then?
I think first of all, it's a compliance question. Right. So the context, as usual with me, as you guys know, the context is financial services, and where did that data flow? Particularly, did it contain PII or other regulatory reporting data? And how was it processed, and where did it go from that point?
Interesting. Wondering whether, like, how would the events scale for this level of granularity?
Yeah, I think that's an important question, right? And particularly as Gen AI engines get adopted more and more across large firms, we're going to have a scale problem. But the first problem is, even at small scale, right? How do you make sure that you're tracking that data flows through those engines, particularly if you're using outsourced compute and outsourced LLMs, right? What was processed through, just picking vendor. I'm not saying these are the vendors in this case, but what did you process through Grok, or what did you process through? So making sure that you can reconcile what PI has been processed through a provider, for instance. Again, start with the artifacts first of all, at the artifact level, like document level. But if you could get into the entity resolution inside the artifact, that would be amazing. Just wondering whether anybody'd seen any solutions out there, and whether there's any thought in the community on. It's interesting that if you actually just put it in a pipeline, that's an interesting thought. Just treat it like a run facet and a data set within a run facet. But when it's more ad hoc, we're thinking both agentic use cases, but particularly human in the loop type use cases. And so it's less nicely pipelined and orchestrated. It's more ad hoc, and that tracing of that data set through those workflows, whether they be ad hoc or pipelined, is the bit that we're trying to get to.
Yeah, I don't have anything smart to say, as I haven't encountered that use case from a customer yet.
Yeah, we part of testing with this community is I want to make sure I'm not missing something, because we haven't found anything. We've not come across any solutions out there. Yeah. So I just wanted to make sure I wasn't missing something.
No, I mean, makes perfect sense. Yeah, and by the way, if I do hear or see something, I'll definitely we'll
Thank you.
take note.
And likewise, I'll bring it back to the community if we put our hands on something. But certainly, we can't find any open standards. We can't find any. You do a Google and Watson, they will start talking about unstructured data lineage, but I can't find any information behind standards they're deploying or anything.
Yeah, there is an LFAI working group on like AI and LLMs. I joined once, but I just don't have the time or technical depth to really do anything there. But if you want to join that, like, it's on the LFAI Slack.
What is the name again?
It is, one second. It's in the LFAI and Data Foundation Slack channel, which is, I can paste it here.
Thank you.
And then the channel, I believe, is called either ML Ops or Generative AI Commons, or GAC Mad Workstream. I'm sure joining any one of these, they can. I started from the ML Ops one, at least.
Thank you.
Thanks for bringing up that topic, Daniel. And for joining our community. Always good to see you. All right, folks, any more topics before I call the meeting? Okay, as always, thank you all for joining. Thank you for being part of the community and the healthy and positive discussions on all the amazing work that the committers here are doing. So thanks to all.
Thank you.
Thanks. Yeah.
See you.
Yeah.